These kit surfers hitching a ride on a moving air mass. Our transparent atmosphere reveals itself when it starts to move. Moving here of course is wind. The atmosphere surrounding us is a deep ocean affair extending for kilometers about us. We know that the atmosphere is essential to life on Earth. The components are particularly oxygen and carbon dioxide play a critical role in the chemistry of life.
Another important aspect is atmosphere pressure. We live on the bottom of the ocean of air. Gravity pulls on the mass of gas, creating pressure. The pressure is the greatest on the bottom. Pressure is force per unit area. The unit of pressure is Pascal. 1 Pascal is 1 Newton per square meter. You also find PSI or pounds for square inch, that is used in some parts of the world, particularly in America. Air pressure at sea level is 14.7 psi or 101.3 kilopascals. That's over than 100,000 Newton per meter.
If you have a small kitchen table, 1 meter square, the force in that area created by air pressure is approximately 101,000 newtons, equivalent to the weight of 10 cars sitting on the tabletop. If air pressure can generate such huge forces, why don't we notice it? Why doesn't the table collapse? It turns out that pressure in a fluid like air transmitted all directions, not just down. This means that the 101,000 newtons of force pushing down on the tabletop is balanced by 101,000 newtons pushing up. Forces are balanced. Similarly, our bodies are not crashed because the fluids contained within our skin exerted a pressure that balances atmospheric pressure.
Experience we have carried out an experiment which proves the existence of the atmosphere. So what do we need for this? We have to get a glass of pure clean water and a short but not big list of simple paper, not of cotton.
I take the list and put it on the edges of the glass. Then I turn it. As you see, water is almost not flowing out. Why? The fact is, the weight of water in the glass is less than the atmospheric pressure force, which holds the list with water. Water tends to fall down and its weight discharges air inside the glass. The pressure in the glass becomes lower than atmospheric one. The air tends to get inside, holding the list standing in the way of water.
Interestingly, we couldn't live without atmospheric pressure. In the few minutes you've spent watching this video, your body has been quietly using air pressure to move air in and out of your lungs. The diaphragm muscle membrane below your lungs alternately contracts and relaxes, changing the volume of the body cavity, which changes internal pressure. Low pressure allows air of atmospheric pressure to move down the trachea into the lungs. High pressure forces that out. Without atmospheric pressure, we couldn't breathe. Atmospheric pressure also plays a role in the function of many devices, including water pumps, syringes, and straws. When you use a drinking straw, you are not sucking liquid up tube. Air pressure pushes the liquid up the tube.